So, two different topics in today's lesson. We're going to deal with complex abstract fractions, some messy fractions inside of fractions. Abstract means we've got letters in all of that. And then rationalizing the denominator when we have square roots in the denominator. So, would you agree this is a messy looking fraction? So it's complex. Would you agree it has letters in it? So it's abstract. So what we're going to do, this has fractions inside of fractions. We look at each of the little fractions inside, and we look just at their denominators, and we want to get the least common denominator. Since they're both p is the least common denominator. Then we take our main fraction bar of that original fraction, and we multiply by another fraction, so we line up the same main fraction bar. And we're going to multiply that original problem by 1. And the special form of 1 is going to be LCD over LCD. Would everybody agree P over P is 1? So I'm taking the original problem times 1, so it's still the original problem. Now, I need to multiply straight across M over P times this other numerator. But to make it a little easier, I can think of that as times P over 1. So the P's cancel, and I have M over 1, which is just M. And I do the same thing, more or less, in the denominator. I'm going to take the Z plus X over P times the P over 1, and so I don't mess up my numerators and denominators. I can put that as P over 1. The P cancels, and I have Z plus X over 1, which is just Z plus X, or X plus Z, and that is my answer, and I'm done. Jonas?
So, also take that fraction and flip the bottom one?
Yes, you can. This way is faster and less writing when you do it that way. And when we get to some of the other even messier ones, this way is going to be a lot faster and more streamlined for you as you do it. But yes, you can always take one fraction, and you can say that is equal to the first fraction times, flip the other one upside down, and you get M over Z plus X. And if you're doing it on a test, particularly where that's already printed, it's a lot faster to write times P over P than to have to write M over P times P over Z plus X to get you to the final answer. A little bit of a question mark sometimes when you're copying from the book. Okay, so this one, here is our main fraction bar. Once again, the fractions match. So I am going to multiply the numerator by x plus y and the denominator by x plus y, which means the x plus y's cancel, and I just have m in the numerator. The x plus y's cancel, and I just have z in the denominator, and there is my final answer. So this next one, I think, will start showing you some of why this way may be easier than multiply by the reciprocal of the denominator. If you have a plus sign in the numerator or the denominator or both, then it's a lot more confusing and a lot more work to get it where it's all written as one fraction, and then you can flip it. If you tried to do it that way, you'd have to first get a common denominator and get the whole numerator written as a fraction. This way, all I have to do is say that here is my main fraction bar, and then I look at all of my little fractions. This has a denominator of p, so does this one, and this one has zp, so my LCD of those is going to be zp or pz, whichever way you want to write it. So I am going to multiply that whole problem by pz over pz, so I'm just multiplying by 1. If it helps me not make mistakes, I can think of each of those as a fraction over 1. Now, in the numerator, I have something plus something times PZ. So I need to distribute PZ times M over P. The P's cancel. I wouldn't write, but you're getting MPZ over P. I would simply write, oh, that's MZ. After the P's cancel, I still have the M, and I still have the Z. This one, I could write it if I wanted to from the distributing, 3PZ over ZP, and the P's cancel and the Z's cancel, and I just have 3. But normally I don't write this part at all. I just say PZ times 3 over ZP, the P and the Z cancel, I still have the 3. And that's my numerator. Then the denominator doesn't have a plus or minus sign in there, so I could write if I wanted to that I have S times P times Z over P, and the P's cancel. But it's pretty easy to say if I'm multiplying straight across, the P's cancel, and I still have the S, and I still have the Z, and here's my final answer. So I wouldn't really write that. And that's where we start getting faster and saving time with it. Questions from anybody with the complex abstract fractions? Okay, then we're going to move on to rationalizing denominators. And we can't have square roots in a denominator, and we can't have square roots of fractions. If I have the square root of a whole fraction, I rewrite that as the square root of the numerator over the square root of the denominator, and then this is the part I have to worry about, because we can't have square roots in the denominator. And I'll go back up to that writing in a moment. So if I had 3 over 2 root 5, who remembers how we get rid of the root 5 in the denominator? Ricky? Okay, we're going to multiply numerator and denominator by root 5 to get rid of the root 5 in the denominator. It'll be okay to have one in the numerator. Again, I'm taking the original problem times 1. So I haven't changed the original problem. You must write it both places. I'm going to count it wrong if you just say I'm multiplying by root 5, because that changes the problem. I need to see the root 5 over root 5. So if we do that, then we get 3 root 5 in the numerator. In the denominator we have the 2. What's root 5 root 5? It's a regular 5. So we have 3 root 5 over 10 as our simplified answer on that. So that's what we have up here. We multiply denominator and numerator by the same radical to get rid of whatever that radical was in the denominator. So a couple more examples. About 3 examples, and then you guys will do some on whiteboards. So actually, this one you could probably just do on your own papers after what we just did. So copy that down. Write down what you think you need to multiply numerator and denominator by. Anu, what do you think we need to multiply by? Okay, so we need to get rid of that root 5 in the denominator, so we multiply numerator and denominator by root 5. And then what do we have, Hendricks? Root 5 over a regular 5. Okay, let's try this one. Yesenia, what should I multiply by here? Just the root 2 is all I need to mess with. So show root 2 over root 2. That means we have 4 root 2 in the numerator and 3 times a regular 2 in the denominator. You may not leave it as 4 root 2 over 6, because if you look at just your number parts, 4 over 6, is that a fraction we can reduce? What does it reduce to? So we need to change the 4/6 to 2/3, so we have 2 root 2 over 3. So you could have done it this way. You could have said, oh, right here, 4 over 2 is a regular 2, and you could have done it that way. And then one last example, but I'm actually going to do this one several different ways, because different students will think about it different ways, and we all get the same answer. But I want you to be aware of some of the choices. So, who has one idea of what we could do to simplify this? Root 12 is 6 over 3. Oh, okay. So, actually, let me clone this a few times real fast here to make life just a little bit easier. So let's clone that, and then we'll clone it again, just to make it easier to do this 3 different ways. So one way we could do it, Anna was saying we can say, oh, we've got the 2 and the 3, but we know that the square root of 12 is the square root of 4 times the square root of 3. So that means that what we've got right here is 2 root 3. And then what would we do to get rid of that root 3 that's in the denominator, Della? By what? So multiply numerator and denominator there by root 3. And that's going to give us 2 root 3 over 3 times 2 is a 6 times a regular 3. So 2 over 18, but I could reduce that. 2 over 6 is a third, so I could say root 3 over 9. Does that way make sense to everybody? Okay, another way that I could do it, I could say, I'm not sure what, but I know I've got a square root in the denominator, so I need to multiply by root 12 over root 12. That's going to give me 2 root 12 over 3 times a regular 12, or 2 over 36, which is 1 over 18. But then I need to simplify the root 12, and like we already talked about, it is root 4 root 3, so that gives me 2 root 3 over 18, and the 2 over 18 reduces to a 9th, and I have the very same answer. Does that way make sense? The other thing that I could do, sometimes I look at a square root and say, oh, let me think about other square roots that I know. I know square root of 25. I know square root of 36, square root of 49, square root of 64, of 100, some of those kinds of things. Can I multiply 12 by something and get one of those? No. So 36 would be pretty easy to get. So if I multiplied by root 3, I'd have square root of 36. Basically the same thing I'm multiplying by right here. But then I could say 2 root 3 over 3 times the square root of 36. So 2 root 3 over 3 times 6. 2 over 18 is 1 over 9. So once again, I get root 3 over 9. And all of those ways are correct. It's just whichever way makes more sense to you. Our brains all work a little bit differently sometimes with our first ideas. Anyone with questions for me?